Hello everyone. In this video, I will explain choosing between application load balancer and network load balancer depends on the specific requirements of your application's architecture, traffic patterns, and the protocols used. Both types of load balancers serve to distribute traffic across multiple targets, but they operate at different layers of the Open System Interconnect model and offer different features. Here's a detailed comparison and an explanation of how each works. Amazon Web Service Application Load Balancer. Layer 7 Load Balancing. Application Load Balancer operates at the Open System Interconnect model's application at Layer 7. It can make routing decisions based on the content of the HTTP/HTTPS headers, URL paths, query strings, and more. Features. Content-based routing. Application Load Balancer allows you to route traffic based on request content, making it ideal for modern application architectures, including microservices and container-based applications. Host and path-based routing. You can route traffic based on the domain name host or the URL path specified in the request. Support for HTTP2 and WebSocket. It supports advanced web protocols which are beneficial for improving performance and real-time communication. Integration with Amazon Web Service. Application Load Balancer integrates well with other Amazon Web Services such as Elastic Container Service, Elastic Kubernetes Service, and Web Application Firewall. Use cases. Applications that need intelligent routing based on content. Microservices architecture where different services are served at different paths or host names. Web applications requiring WebSocket or HTTP2 capabilities. Network Load Balancer (NLB). Layer 4 Load Balancing. NLB operates at the transport layer, Layer 4. It routes traffic based on IP protocol data, such as TCP port and IP address. Features. High performance and low latency. NLB is optimized to handle millions of requests per second while maintaining low latencies. Static IP or elastic IP. Unlike application load balancer, NLB allows the assignment of a static IP per availability zone or the use of elastic IP addresses. Direct TCP and UDP traffic routing. Supports routing of TCP and UDP traffic, making it suitable for applications that require direct connection to the load balancer. Zonal isolation. Traffic is isolated by an availability zone, which can enhance fault tolerance. Use cases. Applications that require high performance and low latency. TCP or UDP-based applications such as gaming servers or stock trading platforms. Situations where a static or elastic IP address is necessary for whitelisting and firewalls. Choosing between application load balancer and NLB. Protocol and routing requirements. If your application requires complex routing based on the content of the HTTP/HTTPS headers or needs WebSocket support, choose Application Load Balancer. If your application primarily uses TCP or UDP and benefits from low latency and high throughput, go with NLB. Performance considerations. For ultra-high performance and low latency requirements, NLB is typically more suitable because of its ability to handle volatile high traffic patterns and its operational efficiency at the TCP level. IP address needs. If having a static IP is crucial for your application deployment, NLB would be the better choice. Integration and features. Consider the additional features like web application firewall integration or the need for detailed routing rules, which might lean towards application load balancer. Understanding these under the hood mechanics and features can help you better decide which load balancer best meets your application's needs. Thank you everyone for watching the video. If you liked it, please don't forget to subscribe to the channel. For more content like this, check out my book, Cracking the DevOps Interview.